Hi everyone, in this video I'm continuing to look at question 13 part C of the 2020 North Sydney Boys Extension 2 trial exam. So in this video I'm looking at part 3, which wants us to find the sum of the area of the shaded region in the diagram below. In the video immediately prior to this we already started looking at this part, and in that video we took the example of n is equal to 4, and that was an example where n is even. So now what we want to do in this video is generalize that result to cater for any situation where n is an even number. And that'll be our first case, n is even, and then we'll have to repeat the process to see what happens when n is odd. So yeah, let's take a look. So I've got my base curve again. Now, so if I just flick back and have a look at what was going on when n is equal to 4, we cut our range in two, and then we cut it in half again, and so on, and that's always going to be the case when n is an even number. We're essentially cutting the range in half and half and half and so on, and the number of times we cut in half just depends on what n is. So I guess in terms of now attempting to generalize, we can know that we're going to have a line at the midpoint at this point 1. And we know that at that point, that line is now going to generate two rectangles, one on either side. So I can definitely draw those in. And then in terms of thinking of this generally, we're going to just have the pattern continue on either side. And then, as was the case when n is equal to 4, for this first point, the rectangle, we actually have a rectangle in this first and last region, so because the rectangles are sitting outside or above the curve. So we can also know that we'll, for example, have a rectangle here, and then another one here, and that will just connect there. And then similarly on the other side we'll have a rectangle here, and then we'll have another rectangle here. So as has been the case with these questions, we want to write out a formula or a summation that will total up all of these shaded areas. And so remembering that the width of these rectangles, now it will just be the generic 2 on n. So what we can say is that the area will be equal to width times height, so 2 on n times the function at this point, 2 on n. And then again, the width will be 2 on n times the function at this point, which would be 4 on n. And then we continue on, and then here the interesting thing is that we get two rectangles, both with this same height. So we'll have a 2 on n times the function at n on n, because this is n on n or 1. And then we do that again to cover, so we've just done that, now we need to do this one. So 2 on n times the function at n on n. And then we continue on, and then we keep the pattern and we end up with a 2 on n times the function at this point here, which is 2n minus 1 on n. Because this would be 2n on n, and this would be the one immediately prior. So every time it's 2 of something, this time it's 2 of n minus 1, and then always divided by n. So now if we think about writing this in summation form, just like we did with our case of n is equal to 4, we can take one of the duplicates and just push it to the end so that we end up with a consistent sum. So that's what we'll do. We'll take this duplicate and push it to the end, and that way we can just write our sum as being 2 on n, factoring out this 2 on n, times the sum from r is equal to 1 up to n minus 1 of f of, and in each case it's 2 times r divided by n. So that's our key summation, and then off to the end we'll add on a 2 on n times f of n on n. Now with this bit here, rather than do all the work to throw in 2r on n into the function and simplify, because we've already done that work, we did it in part 2, we can know that, here we have it here, 2 on n, sum from r is equal to 1 to n minus 1 f of 2r on n. That simplifies to this here. So we can just jump straight to that, I think. So let's just save ourselves some working. So it's going to be equal to 4 times the sum from r is equal to 1 to n minus 1 of square root of r n minus r, all divided by n squared, plus 2 on n times f of 1, and we know that the function is the square root of x2 minus x, so square root of 1 times 1, square root of 1, or just 1. So this is f of n on n will just simplify to 1, so we just get a plus 2 on n out here. And that's it. That's the generic formula for the case where n is even when we're dealing with rectangles that sit above the curve. Now that looked like not much work, but that's because we got to skip a lot of steps because we're just repeating what we've already done in part 2. But as we have before, we can do our check. So let's check what we get when n is equal to 4 here. So we'll get our area as being equal to 4 times the sum from r is equal to 1 to n minus 1, which is 3, of the square root of r times 4 minus r on 4 squared is 16, plus 2 on 4. So that's going to give us 4, and again I'll bring out this 16 to save me a few steps, times the square root of 1 times 3, plus the square root of 2 times 2, plus the square root of 3 times 4 minus 3 is 1. And then plus 2 on 4. And again, I'm just going to throw this into the calculator rather than try and simplify it, just so I can compare against the exact number we plugged in the prior video. So let's just do the square roots first. So we'll have the square root of 3, and we've got 2 of them, so I'll go times 2, plus the square root of 4 is 2, so that's just going to be plus 2, times 4 on 16, and then plus 2 on 4, and what do we get? We get 1.866025404 and so on. Let's just move this out of the way so we can flick back. 1.866025404. So perfect. So we've got our generic formula. The check passes, which gives us some comfort that we haven't made any mistakes. So that's the case where n is even. Now we need to go through that process again, check what happens when n is odd, and see if we get anything different. So I'll do that in the next video. And yeah, I'll see you in the next one.